Okay, hello everyone, welcome. Can you hear me? Hello.
Yeah. Yeah.
Okay, just we are waiting 1 minute, then we'll start today's session. Okay, so we will start today's session. So basically, today is our third number class, and I hope all of you already get the previous recorded video class and also get all of materials. So after completing the 3 hours live training program, then we talk about the problem solving for previous classes. Okay, so let me share my screen. Can you see my screen? Is it visible?
Yes.
Thank you.
Yes.
Okay, so let's go. Okay, so basically today's session we discuss about that how to calculating any indices from satellite images using Landsat or Sentinel imagery. Any types of indices, how we can easily calculate, and then filtering and displaying the satellite images, mainly Sentinel-2, how we can easily filtering and displaying the Sentinel-2 satellite imagery, and further how we can easily monitor the water body using different types of indices. For normalized difference water index we also use, and then how to use the NDVI also discuss about that, and also discuss about the how to extract the water body from NDWI map, how we can easily extract the water body. So this type of technique we also discuss about that, and also discuss about the time series chart using Landsat or Sentinel imagery. So previous class I discussed about the ready-made data set, how we can easily make the time series chart. For today's session is discuss about that how to make the chart using the different types of unready-made dataset, Landsat or Sentinel. So this type of imagery, how we can easily apply and make the time series chart, and how to export any shapefile from Google Earth Engine. We'll also discuss about that, and how to add the legend. Okay, in Google Earth Engine we can also add the legend to display our map, and how to make the flood mapping using Sentinel-1 SAR data. We also discuss about that, and how to create the monthly time series chart, different types of indices using Landsat or Sentinel imagery. Okay, so let's try to explain all of details step by step. Then I hope we can easily get all of idea, and further you can easily apply. So okay, so first of all, okay, let me open my code editor. So first of all, I try to show you that one project for water resource management, how we can easily detect the water body in the flood water or water logging area, how we can easily detect. And then I also try to cover this type of topic also. So first of all, I discuss about that how to detect water body using suppose Sentinel 2 imagery. Okay. So let's go. So first of all, in this time, if you want, you can use at the Landsat, or if you want, you can also use at the Sentinel. So Landsat is 30-meter resolution, Sentinel is the 10-meter. So Landsat Sentinel 2 is more better than Landsat. But when you work with historical data analysis, then you must come Landsat imagery, because Landsat satellite image is available from 1973. but when you work with for the present time condition time, then you try to use here the Sentinel-2, because Sentinel-2 imagery is more better resolution, we find out. Okay, so I'll show the example using Sentinel-2 imagery. So first of all, we need to import our dataset Sentinel-2 multispectral instrument. So here I use here that surface reflectance. So this is my dataset. It's available from 2017 to present time 2025-06-27, and this is the snippet ID. Just I copy the snippet ID and then paste on our study area, just code editor. So now this image collection, we need to store it in a variable. We already know about that. So just before the variable name, just put the var keyword, and you can put any name as a variable. I put the name as a S2, or you can put any name. So now this is my image collection. I simply imported in my code editor, and now I need to filter this image collection. We already know about that filtering process for image collection. So for that, first of all, you need to import your study area. Which area you want to detect the water body? Simply import your study area. So we already know about that, how we can easily import our shapefile on asset tab. We already know about that. So here I already imported my region of interest. So let me simply import from here. Suppose I work for the Dhaka city boundary. Just I imported Dhaka city boundary. It imported. This is the shapefile. Okay. And it show the default variable name as a table, but if you want, you can put any name as a variable. I put the name, suppose RY. Okay. So now I imported my study area and also imported my image collection. So now this image collection I need to filter, and we already know about that filtering process. When you filter the image collection, first of all, where you need the image, then second condition, how, and third condition, when. So using these three conditions, we filter our image collection for Landsat or Sentinel. Both are the same. So now where I need the image, so for that we are just use a function. It's called the filter bounds function. Filter bound, and now put the argument is the RY, because RY is stored my shapefile boundary. Okay, done. So then how basically, suppose in this time I take the less than 1% cloud cover imagery. So for that we are just use a function. It's called that filter metadata for filtering the image properties. We can easily find out the image properties in the image properties section. You can see I want to use, suppose, cloud pixel percentage. Just copy the property name and paste here, and then put the operator. I put here less than, and set the value, I suppose 1. So now how is done? So I need the less than 1% cloud cover. So now when you need the image, so in this time I want to need the image, suppose 2 time period. Okay, suppose I need the image in year of 2024, dry season and rainy season. Okay, suppose I put the 2 season, dry season and rainy season. I create the imagery. So for that I take the full year. Suppose I take the full year, filter date in year of 2024, 1st January, from year of 2024 December 31. So I take the whole year, and further I also filter more for 2 season, dry season and rainy season. Okay. So now if you check how many images are available in the 1 year, just print S2 and use at the size function. So now it's computing how many images are available in the 1 year, less than 1% cloud cover. So we find here total 25 images between this time period. We find out in here. Okay, so now this image collection, further I want to filter for 2 season, suppose dry season and summer season. Okay, so let's go try to filter again. For first one I try to filter for dry season. So for that, just take a variable, suppose dry image, and call this S2, and then filter date again, just apply filter date and put the dry season date. So for Bangladesh we put here 2024 January to 2024 May. I put suppose May 31. Okay, so now let's check how many images are available for that dry image. Just I copy and now check, just use the size function, so computing how many images are available in the dry season. We find another 15 images between this time period. Okay, so now take the another image collection for rainy season or wet season. So for that, just take a variable, suppose wet image, and call the s2 again. This is our collection for 1 year. So now this 1 year collection I filter for a specific season, year of 2024 06/01 from 2024 October 31 I put. Okay, so now let's check how many images are available. So just print, and wait image, I want to check how many images are available for this time. So now it's computing how many images are available. We find out the 0 image. Okay, so between this time period there is no image less than 1% cloud cover, so that's why it show the 0. So now how I can fix it? So for that you try, suppose less than 5%, what happened? For rainy season it will be okay. Let's check it, there is no image also. So now let me check for 10%, less than 10%. Now check what happened. We find out the 2 images. Okay, for this time period. Okay, less than 10%, we find out the 2 imagery, we find out in here. Okay, so now we simply check it. Okay, how many images are available in the dry season and wet season. So first time we check it, less than 1%, 15 images is available. Okay, but when I put the less than 10%, then we find out the 20 images is available in the dry season and 2 images is available for the rainy season. Okay, so now I want to just use this imagery and further I create the composite. Okay, if you want you can also take the single date imagery, but in this time I want to check for composite, and I want to apply suppose mosaic composite. Okay, previous class we discussed about the median, so we just apply here mosaic. So now this 20 images create the mosaic composite, and further I just clip with my study area which is RY. Okay, so same process you also apply in here, just apply the mosaic and then clip with our study area which is RY. Okay, so now if you want simply run the code, we face a problem. You can see it show this type of problem because size is only work for the collection, but now when I apply the mosaic, it's not a collection, it's just a mosaic composite image, single mosaic composite image. So now size is not work now. Okay, we try to display the imagery. So for that, just use here map dot add layer and call the dry image and run the code. So it added the layer. Okay, also add the another layer for the wet season image. And run the code. So now 2 layer is added in here, and I want to focus on my given study area. So for that, just use here map dot center object is my RY and zoom level 10 and run the code. So now it directly focus on our given study area. So we find out this type of imagery. Okay. So now we try to add the visualization parameter for the images. Just click on here, and if you check here, it show the digital number. Okay, it's not show the reflectance value, it show the digital number. So this digital number we need to convert into reflectance value. Okay, So for the conversion, we need to multiply this scale. If you check, this image have already have this type of scale value 0.001, and all of bands are the same, all of bands are the same scale. So when I just use this type of scale, then we find out the reflectance value. Now it show the digital number, but when I multiply this value, then it show the reflectance value. So let's go try to convert using this scale. So now this scale value we need to multiply with all of images. Okay, all of images. Suppose this total 42 images I want to multiply. Okay, so at the same time I want to multiply. So for that, we already know about that. We need to create a function. So for that, just I take a variable name, suppose image rescale, and call this put the function keyword and put the element name, suppose img. So now I just put my argument. My argument is that this image I want to multiply with this scale factor. So for that, I want to return this image multiply this value. Okay, and now it only work for the one element, but I have also rest of other images. So for that, this property I copy. So for that, use the copy properties of this image, and then apply it system time start to system time int. So this function, so now this function we simply connect with our collection, total 42 image collection. So now just call the s2 and use here the dot map function for connecting. So this is the one way. If you want, you can just use the same variable without take the another variable, just copy the same things and then remove this thing it not need. So just I use the one variable. So for that, simply paste here. Okay, so now I just keep the same variable. This is my collection s2. Okay, this is my collection, and this I create this function. Okay, just I use the same variable to create the function to calculate the rescaling value. Okay, so now it's okay, there is no problem. So now run the code. Okay, so now let's check the value again. Just click on here. So now we find out the reflectance value. So I want to add the visualization, suppose red, then green and blue. Stressing 98% I keep, and further just apply. So we find out this type of imagery. Okay, and this visualization I want to add, and then I try to add for second imagery. So further again, just click on here and add red, then green and blue, and stressing 98% I keep and apply. So you find out this type of imagery. Okay, and also import it. So you find out this type of imagery for the 2 season. Okay, you can see. So this one is for dry season or summer season. It's very clear, not much any cloud pixel. But when you open the rainy season, we find out, you can see this type of white pixel, it's a cloud. So this is the rainy season, and this is summer season. We find out in the summer season. So now from this satellite imagery, I want to extract the water body. Okay, suppose from the summer season, I want to extract the water body, as well as I also want to extract the water body from rainy season. Okay, then I want to compare these 2 season for water body. So let's go. We try to compute the water index. and this visualization we try to add. I also add the layer name, suppose weight image, and this one is for dry image. Okay, so now we try to compute the water index to extract the water body from this two season imagery. So let's go. Okay, so for water body extraction, we try to use here one method. There's a lot of index. If you simply search on the Google, suppose water index in remote sensing, so you find out that there's a lot of index for that extraction of a water body. Suppose you can see water index as a monitoring tool. So this is the one kind of index, NDWI, normalized difference water index, and also you can see this is the formula about that. And if you check the another one, this is the water ratio index. Okay, and this is the formula about that. Okay, and if you check, suppose this is another one, MNDWI, modified normalized difference water index, and this is the formula about that. Okay, also you can see, so different types of index we are also use. Suppose in this case I want to apply this one, okay, MNDWI, and I want to extract the water body from our satellite imagery. So let's go. Or if you want, you can also use the any other index, there is no problem, same process. So this is the formula, green minus short wave infrared 2 band divided by green plus short wave infrared 2 band. So this formula I need to compute and apply the two imagery, wet imagery and dry imagery. Then I can easily detect the water body from this satellite imagery. So now how I can compute? So there are a lot of way for computing this type of equation. So I will try to show you that all of way is for after some time. But easiest way is that it's called the normalized difference function. If you simply search here, normalized difference function, yeah, this one, and this function you can see it's only work for the image, not image collection. Okay, we can apply it only for the image, not image collection. So this is the normalized difference function. You try to read all of description. So you can see it compute the normalized difference between two bands. Okay, if the bands two are not specified, use the first two bands. The normalized difference is computed as the first band minus second band divided by first band plus second band. Okay, so in this case it just compute the normalized difference between two bands. Okay, suppose I put the band name band 1 and another put band name 2. Okay, band name band 1 and band 2. So then it computed band 1 minus band 2 divided by band 1 plus band 2. Okay, it computed using this way. So now I want to apply this normalized difference function and I mention the band name, then it automatically computed. Suppose first band I put here green, second band I put here the short wave infrared 2. So when I put the first band is green and second band is short wave infrared 2 band, then it automatically computed green minus short wave infrared 2 divided by green plus short wave infrared 2 band. So let's go try to apply it and then check the result. So for that, just okay, just take a variable. Suppose I put the variable name is MNDWI, suppose dry. Okay, so I take a variable, this type of variable, and now call the dry image. So I already make the dry image. So this is the dry season imagery. I just copy the dry image and paste here and apply the function normalized difference. Okay, so normalized difference, then we need to define our band name. Okay, first band and second band. So green and short wave infrared 2 band. So you can easily check what is the band for green band name is B3, okay, and short wave infrared 2 band is B12, okay. So simply mention in here B3 and B12. So put here the B3 and also put here the B12, okay. So we find out this type of band. So now this function computed as B3 minus B12 divided by B3 plus B12, okay. So now if you want, you can simply add the layer, map.add layer, and then copy and paste here. Should display the MNDWI map for dry season. We find out this type of map as a gray color, okay. We can also add the color for it, and for that just simply click on here, and if you check, it show the ND, okay, it show the default variable name as a ND, but if you want, you can also rename it, okay, just simply rename. So for the rename, just use here the dot rename function, dot rename, and I put the rename as a, suppose you can put a name, I put the name is that MNDWI, okay, okay, for right, I put this type of name. So now run the code again. Now if you check the name, it show this type of MNDWI dry, okay. So now we're going to add the color plated to display. So I keep the 98% for stressing level. So now I add the color. Suppose low negative value I want to display as a this type of red color. Then I want to display this type of so this type of color, and water would I want to display suppose this type of color, and then apply. So now it show this type of map, okay. Just let me import the visualization and then copy and paste after the object name, okay. Then put the layer name, I put it's a dry MNDWI, okay, map. So we find out this type of map. So now water body display as a this type of blue color indicating about the water body. We find out in here. Okay. So now I want to create the same things for that rainy season. Okay. So just I copy the same code, and then now I apply for rainy season. So for that is simply change the variable name. Suppose aim in for the wet, and also change the variable name. I put the variable name, it's a wet image, just call the wet image, okay. And now I apply the normalized difference between two band, and I rename it as a NWI wet, okay. And now display this layer, just I copy and paste here, and also put the layer name, it's a wet, and on the code. Okay, so let me add it again. So I put the empty and run the code. Okay, I put the blank visualization, and further I try to add. Okay, so now we try to add the visualization again. So for that, click on here, expressing 98%, and put the color I keep the same color combination. And now apply. And also import. Then copy this variable name and paste after the object name. Okay. So now you find out this type of map. If you check,
Shouldn't we run the code again?
yes. So we find out this type of map. Yeah. So we find out this type of map. Yeah. So this type of blue color, it is the water body, and this is the map for rainy season, okay, or wet season, and this is the map for dry season. Okay, you can see. Okay, so you can see this type of place. We find out the water body in the rainy season. Okay, but dry season, you can see there is no water. Okay, it show the not any blue color pixel. Okay, so this type of place, but when you open the rainy season, we find out the water body. Okay, if you check, suppose I want to check the pixel value for this type of water body, just click on here and click just apply. So you find out, you can see negative. Okay, negative pixel means that there is no water in the dry season. Okay, but in the wet season we find out the water, very high water. Okay, for this coordinate or for this location. In the dry season there is no water. Okay, negative value indicating about that no water body, but positive value indicating about the water body. So further we find out this type of high water in the rainy season, but dry season it show the negative pixel. Okay, which is indicating there is no water. So let's check another. Suppose just click on here. We find out the negative value. Okay, but you can see we find out that positive value in the rainy season. Okay, dry season we find out that negative value indicating about that there is no water in the dry season, and this value indicating about the positive value, it's indicating about that water body. Okay, okay, so any question you can ask me, please. Yes. Yeah, any question?
Can we calculate the surface area of
Yes,
water body surface area?
Yeah, we also discuss after some time. Yeah.
Okay.
Okay, I hope there is no question about this topic. Now, this type of code or any confusion, you can ask me about that. Anyone?
Yeah, I have a question.
Please.
In the first part,
Yeah.
From line 3 to 7, I think. Yes, can you explain a little bit more the function to scale the image? Because, well, first of all, why to scale the image collection?
Okay, so basically in this time in Google Earth Engine we find out the digital number. Okay, so we find out the digital number. So this digital number we need to convert into reflectance value. Okay, so for conversion digital number to reflectance value we need to use this scale. Okay, this we need to scale. So for that, this scale we need to multiply with all of images. So for that we create this function and multiply and connect the function with our collection. Okay, using the map function. Okay, so in this time I just use the same variable, or if you want you can also take the different variable and then make the function and calculate. Okay, but in this time I just keep as the same variable. Okay, so otherwise we need to change again and again this type of variable, also need to change this type of variable. So now I just keep the same variable, so that's why further I don't need to change. Okay.
Okay.
Yeah.
All right. Thank you.
Okay. So now we find out this type of map, and this type of map we can also export it. Okay, for exporting, just use the same code, export image to drive. Suppose when you make the research paper, then we need to export this type of data, and further we need to make the map using ArcMap or QGIS software. So then you need this type of things. Okay, so all of layer we can easily export it, the same process, export image to drive, and then make the map using ArcMap or QGIS software for our research paper or presentation. Okay, inshallah 5th number class I discuss about that, how to use the ArcMap, mainly ArcGIS, and make the map after downloading this type of GeoTIFF file format. Okay, so now we find out this type of map, and now I want to compute, make the water body. So now I want to check the water body area. Okay, and also compute the water body area. Okay, how much water body increase in the rainy season, or how much water body in the dry season. So this type of things we try to discuss about that. So for that, if you want, so in this time this is the map. Okay, this is the map. So from this map I want to extract the water, only water I want to extract. Okay, only water body, because in this time I don't concern about the other classes. Okay, it can be vegetation or build up area, so I don't need, I need only for this type of blue color pixel. So how I can separate this type of blue color pixel? So for that we create okay, so let's go. So for that, just take a variable. I put the variable name, suppose dry water, and call the dry mndwi. So from here I just take greater than 0. Okay, all of pixel greater than 0 I take. Okay, and remove all of negative pixel. Okay, so let's go try to add the layer. So map dot add layer, and call the dry water. Okay, and run the code. Okay, so it show this type of place. Okay, so this type of white color area, it's in the water body. So it look more better if I just use a classification. Suppose I put the two class 0 and another for 1. Okay, and also add the two color, water body and non-water body. For non-water body I want to show as a, suppose, gray color, and for water body I will show as a blue color. Okay, and run the code. So now we find out this type of map. So basically this type of gray color, it's the non-water, and this type of blue color is the water body. Okay, yeah, any question please?
Yeah. So what does the operator GT dot do? I mean,
It's greater than greater than
okay.
greater greater than 0. We take the all of pixel greater than 0, which is indicating about the water body. Okay, and then we find out this type of map. Okay, for that water body map. Okay, and this water body map we generate from this index. Okay, from this map we are just simply it's a weight. Okay, this map. Okay, this is the weight mdwi. So from the weight mdwi we generate this type of map. Okay, if you want you can also create the single layer also. Suppose in this time we create the binary class 0 and 1, 0 for non-water, 1 is for water. Or if you want you can just keep only for the single class. So for that we just use a function, it's called the self max function. Okay, and then when we apply the self max function, then we get the result only for the one class, only for the water body area, water body map. So for that, just remove the 0 and 1, it's not now need. I put the plated and put the water body color as a blue, and then set the layer. I put the layer, suppose dry water. Just run the code. So now it's create the single layer. Okay, just we find out only for the water body. So we find out this type of map. Okay, only for the water class I find out this type of blue color. So now there is no gray color, just remove. Okay, just I make the single class. So this is the one way how to create binary class to single class. Suppose I have a binary class, so from this binary class I want to display only for the single class. So for that, just use the self max function and define the one color. So now the same things I also apply for rainy season or wet season. So for that, just call the mndwi in the wet, just call, and then apply it in here. Okay, and put it, it's a suppose wet water. Okay, and I want to display it. And now I want to display it as another color, so then we can easily differentiate the two season water body. Okay, wet season and rainy season. So I want to put the wet season water body as a red color. Okay, red color is indicating about that wet season water, and blue color is the dry season water. So just run the code. So now if you check, we find out this type of red color indicating about that wet season water or rainy season water. And if you check here, the dry season water, okay, also this type of is the dry season water. Okay, but we find out the wet season, it also increase this type of place. Okay, you can see increase this type of place, and also have this type of place also. Okay, this place also have the dry season water, and wet season or rainy season also find out the water. Okay, you can see we find out the water blue color. So now how I can calculate how many water body increase in the two season, in the wet season, how many water body area increased. So you can check, we find out this type of place was water body in the dry season, and then open the wet season or rainy season, it also show the water body, this type of place also water body. Okay, but we also find out this type of place have also water body in the rainy season. So now I want to compute it, how many water body area increased in the rainy season. Okay, so for that we are just create the histogram, and from the histogram we take the threshold value, and further this threshold value we are just use and then make the decision. Okay, so let's go and try to explain about that, how we can easily apply the thresholding technique and then separate the calculate the how many water body area in the rainy season. Okay, so for that, just print. Okay, just take a variable. Suppose I put the variable name is that hist for try. Okay, and then apply a function, this function called that ui dot chart dot image dot histogram, and I want to make the histogram for mndwi for try. Okay, for this, and paste here, and then put the study area as a ry regional, and then scale 10 meter. So now print. So print the histogram. I also put the some notation. It's a dry. Okay, and this same thing we also do for rainy season, okay, or wet season. For that, I simply put here histo wet and call the mndwi in the wet season and paste here, and then print this variable. I put it's a wet and run the code. So now it generates the two histogram in the chart. So from the chart we can get the value, okay, and from this value we can get the decision. What is the threshold value to identify water body in the rainy season? Okay, so we find out this type of result. If you check, this is a dry season and this is the wet season, we find out. So now if you check, just open the dry season. So if you check for the dry season, what is the highest value of mndwi? Okay, so you can also check it. You can see what is the highest value for that, or you can also download the data and also check it, or also check the value. You can say 0.3 or 0.398 or 0.43. Okay, so we consider suppose 0.43. This value is the highest value, okay, of mndwi. 0.3 or 0.4 or 0.3 we consider from this threshold value 0.3. Okay, so this is the highest value of mndwi in the dry. Okay, so let's go also note down. So we find out that dry mndwi highest value is that 0.3 I consider. Okay, from the chart we take. Okay, and then also check what the highest value for this wet season. Okay, for the wet season, if you check, it show the result 0.3 in here, or 0.3, and then you can see this is the rest of the others pixel, which is indicating about the rainy season water. Okay, so now check the what is the highest value. We find out the 0.8, okay, or 0.8 is the highest. Okay, and for the dry season we find out the 0.3, okay, or from here, and this type of pixel from 0.3 to 0.8, so all of those pixel consider about the rainy season water body. Okay, all of those pixel. So now we find out the 0.8 in here. Okay, so we find out that wet season, wet mndwi equal to 0.8. Okay, so now from this threshold value we just make a condition, and then we are just easily separate the rainy season water body. So for that, just I put the condition mndwi wet less than 0.3, okay, and mndwi dry less than 0.3. Okay, so from the wet season greater than 0.3 of pixel, and from the dry season less than 0.3. So between this condition, all of pixel indicating about that rainy season water body. Okay, so let's go try to apply it and then check what happened. And how we can easily apply, it's very easy. Just take a variable. I put the variable name, suppose rainy, suppose rainy water or rainy season water. You can put any name as a variable, and now call the mndwi wet season or rainy season, MNDWI, wait, these things, and put here greater than 0.3, and also call the dry, MNDWI, dry, put here less than 0.3. So now I want to just apply this condition and create this variable. So now I want to display it and then check what happened. Just I want to display the layer and run the code. Okay, so now we find out this type of place. Okay, we find out this type of white color. It's indicating about that rainy season water body. This type of white color indicating about that. This type of white color. And okay, let me show the display the color, then it will be more better. So for that I want to apply the color, and I want to apply the color, suppose okay, create the single class for the self marks function, apply, and also put the color plated, I show as a, suppose it's a suppose pink color, and put it's a rainy water. So now run the code. Now if you check, we find out, yeah. So now we find out, we can see this type of place. We find out that water body as a rainy water body. Okay, this type of place, and this type of blue color, it's indicating about that your dry water. Okay, this type of blue color is indicating about the dry water, and this type of place indicating about that only for the rainy season water. So now we simply separate. Okay, so now this pink color, it's indicating about the only for the rainy season water. And how I can separate these things, we are just use the thresholding, and we can get the thresholding value from this histogram. And now if you check, suppose I have to check the pixel value for that, click on here, pink color. So we find out the pixel value, it maintain this condition. So if you check the pixel value, we find out that MNDWI negative 0.2. Okay, negative 0.2, but we put here the greater than 0.3. Okay, so it also maintain our condition. So it show the greater than 0.3, but we find out the negative value, and also find out that less than 0.3 from dry less than 0.3. So we find out that 0.8, oh sorry, we find out the 0.8 for that greater than 0.3 I put in here. So now we find out the MNWI is the greater than 0.8. Okay, so we maintain this condition, we put the value greater than 0.3, but for my pixel we find out the 0.8. Okay, and also put the less than 0.3, but we find out the negative 0.2. Okay, so now it also maintain this condition. Check the another pixel value. we find out the 0.8, okay, which is greater than 0.3 from MNDWI wet season, okay, and we find out the negative 0.3, so we find out the less than 0.3 for the MNDWI in the dry season. So it also maintain the condition about that. So now we can easily differentiate about that rainy season water and also dry water. So this type of pink color, we find out the water body in the rainy season. So now how much water body we find out in the rainy season, we try to compute the area. And before that, let's discuss about the flood mapping. So in the flood mapping, we also apply the same condition. Suppose I just create the map for post flood and post event and pre event. We create the two composite of imagery, and further we also apply the same technique and then identify for flood inundation area. So let's try to show you that also. And any question you can also ask me about that, or any confusion about the code you can ask me. Any question, please? Yeah, any question, please?
Is there a pattern that you can use to extract the maximum value from the histogram?
Yes.
Instead of
Yes.
just extracting them visually?
Yes. So in this time we find out that two histogram, if you check. So this one is for our dry season. Okay. In the dry season, if you check the dry season, we find out that 0.3. Okay. Or 0.4. We also consider, there is no problem. So 0.3 or 0.4 is the highest value of the MNDWI in the dry season. Okay. This is the highest value. And if you check for rainy season, the highest value is that 0.8. Okay, so this is the highest value of the rainy season. And if you check compare, suppose this chart I just simply overlay with this chart, then we find out the 0.3 in here. Okay, 0.3 in here, and then others. Okay, greater than 0.3, all of pixel indicating about the rainy season water body. Okay, so greater than 0.3, all of pixel up to 0.8, all of pixel indicating about the rainy season water. So now from 0.3 to 0.8, all of pixel we display as a pink color in this map. Okay, okay, so this same thing will also apply. So I will show you that. Suppose let me open another code editor. Yes, please. Any question, please? Any question?
Sorry, can you hear me?
Yeah, I can hear you, please.
Oh, okay. My question
Okay.
if is there a difference if I
Okay.
don't
Okay. Sometime buffering,
run
cannot hear you properly.
a process that in my from the Copernicus page? Because in Copernicus page I can't find or there isn't an harmonized product of Sentinel.
I cannot get you properly. Okay, kindly again ask me, please. Or you can also write the question. It also more better.